Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, in this episode of ICAR training, we're going to be looking at some sample questions with their solutions from the ICAR examination. So as you know, ICAR has a lot of subjects, so we're going to be looking at some questions from different subjects, and we see how to solve them effectively. So let's start off with a question from biology. Which of these options contain an exclusively marine, radially symmetrical, and diploblastic organism? Is it Pila, Nereis, Pleurobrachia, or Asterias? So, which of these options are correct? Pila belong to the snail family. So they are, first of all, they're not exclusively marine. Second of all, they are triploblastic, and they are bilaterally symmetrical. Now, what about option D, Asterias? Asterias contains the starfish, and in the Echinodermata group, the organisms are radially symmetrical, and most of them are marine. However, they are triploblastic organisms. So therefore option D is incorrect. Nereis belongs to phylum Annelida, the earthworm family. So again, these are radially symmetrical, but they're not exclusively marine, and they are triploblastic. So therefore, option B is also incorrect. The right option is option C, Pleurobrachia. Now, Pleurobrachia belongs to the phylum Ctenophora, which contains exclusively marine, radially symmetrical, and diploblastic organisms. So therefore option C is the right option. Pleurobrachia is an exclusively marine, radially symmetrical, and diploblastic organism. Next question. An ecosystem which can be easily damaged but can recover if damaging effects stop will be having low stability and high resilience, high stability and low resilience, high stability and high resilience, as well as low stability and low resilience. So which of these is correct? For that, we need to understand the terms stability and resilience. Now, stability means hard to damage, and resilience means recovery rate. So in layman's terms, resilience refers to the recovery rate. So if something has high resilience, it recovers faster. If something has high stability, then it offers resistance to damage. If something has low stability, it can be easily damaged. So we have an ecosystem here. Its qualities is that it's easily damaged, so that means it's low stability. But the question also says that this ecosystem can recover if the effects stop. So therefore, it means it'll be having high resilience. So therefore, the correct option turns out to be option A, low stability and high resilience. If it was high stability and low resilience, it would be hard to damage, but does not recover as fast. And if it was high stability and high resilience, it would not be easily damaged. If it was low stability and low resilience, then it would not recover fast. So therefore, option A turns out to be the right option for this question. Now, let's look at chemistry. All right? We need to find out the correct option for the structures of acrolein and peroxyacetyl nitrate among the following options. So we have four pairs of structures. We need to find out which of these pairs is correct. So let's look at acrolein. Acrolein has the IUPAC name 2-propanal. Now from here we can gain a lot of details. Al means that it's an aldehyde. So that means it would have a CHO group. Now, before the al suffix, we have E and N as the letters. So basically, it means that it's a type of propene, which means that it would have a double bond between the carbons. And that double bond occurs on the second carbon. So it's between the second and third carbon instead of the first and second carbon. So if the double bond was here with the carbon with the functional group, it would be called 1-propanal. However, it says 2-propanal, so that means the double bond occurs between the second and third carbon. So since there's a double bond, there's an H here, and then there's two H's here. So therefore, this is the structure of propanal. And if you look at the options, you can see that options 1 and 2 both have the correct structure for propanal. Now that means options 3 and 4 are incorrect, because over here the structure that they show is propanal, which is an alkane. Here it's an alkene, which is converted into an aldehyde. So now that we've narrowed down our options, let's look at peroxyacetyl nitrate. Now first of all, since it's a nitrate, it'll be NO2. And again, this is peroxy, that means there is an oxygen group linking the two sides. And acetyl means that it will have two carbons, and one of the carbons would be attached to an oxygen, so it will be having a carboxyl group. So therefore, peroxyacetyl nitrate would have the structure like this. So it has N plus, an O minus, then a double bond to another O, and then there's a third O that connects it to the carboxyl group of the acetyl. So this here is the structure of peroxyacetyl nitrate. And if we look at the two options, we need a double bond with an oxygen here. So therefore, it is clear that option 2 turns out to be the right option. Option 1 does not have that double bond, so therefore it does not work. So therefore, option 2 turns out to be the right option. 3 hydrogens for the first carbon. The second carbon has a double bond with an oxygen and then a single bond with another. That has a peroxide bond with another oxygen, which is connected to the nitrogen atom, which is positive, connected to an oxygen negative atom, and also connected with a double bond to a neutral oxygen atom. So this is the correct structure for peroxyacetyl nitrate. So the correct option for both acrolein and peroxyacetyl nitrate turns out to be option 2. Option 1 has the second structure wrong. Option 3 and 4 have the first structure wrong. So therefore, option 2 turns out to be the right option. Now let's look at the final question for the day. Consider the following reaction. On the reactant side, we have aniline, which gets converted to nitroaniline. Now here we see the division of the nitroaniline. So nitroaniline can be classified as ortho, para, and meta, depending on where the NO2 group sticks. If it's directly opposite to the NH2 group, then that's para. If it's close to the NH2 group, that's ortho. And if it's one carbon away from the closest carbon, then that's meta. Now, if you look at the reaction here, the para isomers is the highest amount, which is 51%, and ortho is the least with 2%. However, the meta isomer of nitroaniline turns out at a very high rate of 47%. So here the question is asking us, why is it that there is a significant amount of meta isomers? So we have 4 options. The first option says NH2 group is ortho, para, and meta director. This option is incorrect. The NH2 group is basically an ortho para director, and it does not direct much to the meta group. So option A is incorrect. Option D says low temperature increases the amount of meta isomer. Again, this is incorrect. The low temperature is for the fact that aniline is A, highly volatile, and B, highly reactive. So therefore, that's why the low temperature for the reaction. So option D is incorrect. Option C, there's less steric hindrance at the meta position. That is incorrect, because that explanation applies for the para group. We have the highest amount of nitroaniline as the para isomer, and that para isomer has the least steric hindrance. So therefore, option C is incorrect. The right answer is option B. Anilinium ions are formed during the reaction. Now, as we have seen, the NH2 group in aniline is an orthopara director. However, when it reacts with acid to form nitroaniline, because it's acidic, it forms the anilinium ion. Now, the acidity and the anilinium ion together contribute to more meta isomers. So therefore, option B, anilinium ions are formed during the reaction because it's reacted with nitric acid and sulfuric acid at 15 degrees Celsius. Because of that, there are more anilinium ions forming, and the anilinium ion itself, is a meta director. So therefore, option B, anilinium ions are formed during the reaction, is the right option. So that concludes this episode of ICAR training. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rankmate, your partner in education. If you want to get the latest updates from our channel, then please don't forget to hit the bell icon present below the video. So until the next webisode, take care, stay alert, bye-bye for now.